this is DoXDF, and today we're doing Sans Holiday Hack 2023, the Reportinator. So they give us this penetration test report here with a bunch of findings. There's 9 findings, and for each of them I have to figure out which ones are legit and which ones have hallucinations because they were written by AI. And I'll show how to solve this the legit way in my write-up, and I'll have a link to that in the description here. But what we're going to do today is hack this, right? So I'm just going to pick a couple findings. Let's pick 1 and 3 and set them to bad. And I'm going to right click here and go to inspect, open up my network or my tools here, my dev tools, and go to network. And now I can submit the review, and it says it failed. And here we are over here, make it a little bigger. I've got this request. So we can see here, this is a post request to this URL right here. It's returning a 400, which is a failure. You can even see bad request. That's kind of a weird failure, but okay, we'll take it. We can look at the specifically at the request itself. We can see that it sent inputs 1 through 9, with the 1 being the failed, 1 being where I said, oh, this is bad. If we want to see it raw, we can actually see the string and what it looks like. It's a standard HTTP request body with the different parameters, equals their value, and then an ampersand separating them. And we can look at the response, which is JSON for error failure. Whenever I'm going to try to take a request like this that's made for browser and human interaction and try to automate it in Python or in some other language, you want to grab as much of these request headers as you can. And you can always pare it down later once it works, but if you don't have things, the server might not react, right? It might expect a certain refer or origin, etc. Now, in playing with this quite a bit, I'm not going to go through it all here. The important ones to have here is you have to have this cookie, this Reportinator cookie, yum, etc. has to be there, as well as it's important to specify your content type. Because if you don't specify your content type, the server doesn't actually know how to parse the data you're sending it, and it just fails. So with that, let's go ahead and jump in and start writing a little bit of code to brute force this. Let's see, touch brute reportinator.py. I'm here in VS Code. We're going to open this up. I will always start with my shebang, Python 3. We're going to do this with asynchronously. So the typical old model, especially in Python, is you use the requests library and you send one request, then another, and you wait for the response, then you send the next one. It'll take a while. We're going to use the httpx library and async IO to handle this asynchronously. So we'll import async IO and import httpx. And we're also going to import from iter tools, import product. And product is what's going to allow us to easily say, hey, give me all the combinations of 1s and 0s that are 9 long. So what's this going to look like? At the very top, let's define some things that we're going to need so we can get it here. We want this URL for sure. Grab that right there. Paste that in. We're also going to need the headers that we talked about. So we'll say that is equal to this. And we can grab, oops, I got to stop alt tabbing here in my VM. This cookie right here is one thing we need. And we can say cookie, paste that in. Like that, looks good. And we're also going to need the content type. We should be able to just come up with it on our own, but we'll grab it here anyway. And this will need a, there we go. And so I think those are our things we have to do. We'll make a async def main. And again, because we're working in async here, we're going to have to make all of our functions asynchronous. So what are we going to say? In our main, we're going to say async with httpx.async client as client. We're going to say tasks equals, and we're going to define all our tasks here. And we'll say responses equals await async io.gather, and we'll pass it all the tasks. Basically, what we're going to do is we're going to define all the functions we want to run, and then we're going to, this right here, async io gather, is going to basically say, block here, don't continue until all those tasks are done and you've gathered all the responses, and then we can process them. Now we haven't defined any yet, but we're gonna come back to that. So now we can say for response in response is, we know what the response looks like. So if failure, I believe it was all caps, right? Let's double check that. Response, yeah. Failure, bad, ooh, bad. In response.text, I guess we want if not failure. Print response.text. We'll also want to print like response.request.content. That'll give us the body that we can see what we actually sent, because we're going to get all these requests at once. So we're not going to know which one's which. So that'll be good right there. And that looks basically like what we need for main. We can then do the standard Python if name equals underscore main like this, and we can do async io dot run main. And that just lets async io handle the event loop and all the other asynchronous things for us. That looks pretty good. Okay, so first thing we got to do, combinations equals. Is that the name of it? No, product. Okay, cool. So we can say list product. Now product, we're going to give it an array of the options, so 0 and 1. Those are the options, and we're going to tell it repeat equals 9. Because we want 9. And so what that's going to do for us here is it's going to create a, let's see, try that there, looks better. It's going to say those are your options, 0 and 1, and repeat. And so it doesn't, with product, I can have 9 zeros, I can have 9 ones, I can have any combinations, it can be all the combinations. And so we actually know, because these are bits, 1s and 0s, there's going to be 2 to the 9th possibilities, 256. So what is our task going to look like? Well, let's see. We need a function here first. So let's come up here and do async def test combination. It's going to take in a combination, and we're going to pass it in the client. And for now, we're just going to say pass. We come down here, we can say, okay, so what is our tasks? We can do test combination on x comma client for x in combinations. And so for each, what we're doing here basically is saying for each combination we have, pass them into this function, which we're going to then call tasks, and we're going to then use the gather function to wait for those to all finish, get the results. We actually probably don't even need this list here, I'm going to guess, because the reason you add that list is this product returns kind of like a generator, which is like, doesn't give you all the data up front, but kind of waits for them to be looped over. And you can use list to turn it into a straight list. But here we actually are going to loop over it, so it's fine if we want to just do it here. So that'll work nicely. All right, so we have now our thing. We just need to pick what do we want to happen here. In fact, we could show this. We could do print combination here. This is kind of a silly thing because we're not even using it. But now if we do Python brute force report, we're not going to have responses in front of the text. Let's see, what if we just do pass here? Oops, save. Well, that's a tangent. Maybe this is not worth going down. I'm not sure why. Save. Python brute coordinator. None type has no attribute text. Oh, failure here. Wait. Okay, this is a tangent. We don't need to do this. Let's go back up here. So what are we going to do? I was just trying to show this. Going to print all the combinations. You'll trust me. This will make combinations. We need to make a request that looks like that thing. So we're going to do something that looks like response equals wait client dot post, and we're going to go to URL. Our data is going to equal. I'm just going to call it for a second. I'm going to call it post body, and headers equals headers. So that's going to be our thing. That's going to be our thing, and we're going to return response. Now we got to define what is post body, and we saw that before here. Request. Let's get the raw. It's going to look something like this. So what do we want to do? So we're going to have pass in something that looks like, I don't know, like this, right? With, I don't know how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. So how do we turn this into that? Well, we want to, we know there's going to be a counter going up here. So what we can do is we can say, we'll say enumerate combination like that, and we want it to start at 1. So now we're going to get, if we loop over this, we're going to get pairs of things. We're going to get the number 1, 2, 3, 4, 5, and we're going to get the 1 or 0, right? And so we can say that is that'll be I and V. We can say like I comma V for IV in that. So now we just made like a list there. Now we want to turn this into a string though, right? And so the string is actually going to be, do this, we'll do, we want, this is going to be dollar, like not do it up there. Make this a format string so we can say I equals V for IV. So we just made this little part right here, like the 2 equals, the 3 equals, etc. And now we just need to join those together with this string right here. So we can say v join that, and that will actually make our post body. So we can say post body equals this string dot join, and that'll make that look good. All right, I think that we might be ready to go. Let's give it a try. Nope, not quite. Let's see. None type has no response equals that. That looks fine. Responses equal together. Response. Let's see. Let's make sure we're saving this and then running. Okay. So and now you can see it's actually hanging. It's making all those requests for us, and boom, we got some results. We had a couple results that came back positive, which is interesting. I got the same hash twice. Let's see. One, and so it almost seems like it doesn't matter if 1 can be 1 or 0, interestingly enough. Oh, interesting. Actually, I'm surprised this worked at all, to be honest with you, because what's interesting is, I wonder if you just need to have the correct, we left something off. You can probably see it. Our string here is missing a starting input dash. In fact, so we can add that. So we'll grab this right here, copy that. What we really wanted to do was do that plus like that, and that'll give us the right answer. What's interesting is we learned something about so we can see 1 was supposed to be 0. What's interesting is it seems like if we don't pass in something that is meant to be, so it's not verifying whether 1 is 0. It's just verifying. It must just be verifying that. I don't know. That's weird. That's an interesting little finding. I might have to go dig in that more later. But you can see we actually got the results we're looking for here. So we can see that 1. So the hallucination ones are 3, 6, and 9, and that does match what I found when doing this the right way. Just because I like to be a little bit crazy here, we can clean this up a little bit, make this look make our output print a little prettier. For one, let's go ahead and return combination here as well. And so now we can do response comb. So now each of our responses is a tuple, and so we'll get both those things together. And now, rather than printing this, we can say like, we know if there's no failure in response to text, we want to get this combination, right? So we'll say, we want to know, the combination again is 9 1s and 0s. We want to know which numbers are bad, right? So we will say enumerate com, just like we did above. And what we want to do here is sort of say, we're going to say I comma v in that. So we are going to want I for I comma v in that if v equals 1. And that will give us bad findings equals. So now we could say print bad findings. And then here we can do maybe just we'll join these with a comma. Join bad findings like that. And we run this and we see what we get. Expect a string. Oh, we better make this. Right now it can't join together integers. So if we turn this into a string, it will work. And there we go. Bad findings 2, 5, and 8. 2, 5, and 8. We wanted 3, 6, 9. That's because we actually have to have our enumeration start at 1 and not 0. So when we do it this time, we should, within a second, there we go, bad findings 3, 6, 9. So anyway, that is how we can brute force and sort of cheat our way through the Reportinator. Hope you learned something today, and I'll talk to you next time.